In these examples, we're going to use the remainder theorem to evaluate a function at a given value. The remainder theorem tells us that if we plug a value into a function, whatever answer we get is the same as the remainder we would get if we did long division or synthetic division. This is helpful to us to quickly figure out whether a number is going to be a zero of a polynomial, because if we get 0 as the remainder, that means that the factor would divide evenly. So for this first example, we're going to take -3 and plug it into the function that's given here. So let's find f of -3. So -3 raised to the 5th power, and then to the 4th power, squared, and then plus 2. All right. So let's see, this is going to be 2 times -243 minus 3 times, that's 81. This will be -27. This will be +9, and then plus 2. All right, let's see, this is -486 minus 243 plus 243 plus 72 plus 2. And then plugging all this into the calculator, we get -412, which is not 0. So this doesn't really help us. In this case, all that this tells us is that if I have x plus 3 as a factor, it's not going to divide evenly into this function, or this function that I had here. And so I would want to try to find a different value to probably try to break that polynomial down to something smaller. Let's do another example. In this example, we're trying to see whether x plus 1 divides evenly into the polynomial. And so what we're trying to do is we're saying, well, if x plus 1 would divide evenly, then that means that the 0 would have been -1. So we're going to find f of -1. So let's see, -1 to the 4th power plus 5 times -1 cubed minus 4 times -1 minus 17. So this is 1 minus 5 plus 4 plus 17. And that is going to be 17. Is that a plus or a minus? Oh, this should have been a minus here, right? Oh, from the beginning here, this was a minus 17. All right, so we're getting -17 as our value, which is not 0. So again, this, this binomial x plus 1 doesn't divide evenly into this. We're going to use this for some future videos.